Okay, welcome back. This is another video on factoring quadratic trinomials, just for those of us that need just a little bit of extra practice, because this is such an important mathematical concept that we really need to make sure that we're completely fluent in this, okay? If you haven't checked out the last video, I'll go ahead and have a link at the top right over here, okay? So make sure that we check that out if we have not already, because we did cover some of the basics. So remember, when we're factoring quadratic trinomials, we need to make sure that they're in standard form, which is ax squared plus bx plus c, and we're always finding two numbers that multiply to the values of a times c and add to the value of b. Remember, a, b, and c are just real numbers, okay? Like 5, negative 18, 37.2, okay? Although you're never going to have like decimals. I mean, you could have decimals, but we're not going to cover any of those cases because those kind of suck, all right? So, for example, let's say we had x squared minus 11x plus 30, okay? So remember, factoring is undoing multiplication. So there were two binomials out there that when we multiplied them together, they ended up giving us this expression. We need to figure out what those two binomials are, okay? So in this case, a is 1, b is negative 11, and c is 30, okay? So what we need to do is we need to find two numbers that multiply to a times c, which would be 1 times 30, which is 30, and add to b, which is negative 11, okay? Now, once again, really make sure you think of these numbers. And if you have to make like a list of all the numbers that multiply to 30, feel free to do so. I mean, it doesn't hurt, okay? And in this case, one thing you have to be aware of is that we're multiplying to a positive number, but we're adding to a negative number, which means all of these pairs have to be completely negative, because a negative times a negative gets a positive. And if you look here, negative 6 and negative 5 are those two numbers. Negative 5 times negative 6 gets us positive 30. Negative 5 plus negative 6 gets us negative 11. Okay, so these are the two numbers that we're going to use. All right, so we bring down our first term, bring down our last term, and we split the middle using those two numbers. And we split the middle using those two numbers. Okay, and remember, it doesn't matter in what order you have these two. You can have negative 6x and then negative 5x, or you can have it just like this. It doesn't technically matter, okay? But now what we do does matter. We have to go ahead and actually what we call factor by grouping, because we group our first two terms and we group our last two terms and we factor. We take the greatest common factor out of each group, okay? And if I look here, between x squared and negative 5x, all I can do is factor out an x. All I can do is factor out an x. Now leave me with x times x minus 5, okay? Now, if I look at my second group, I have negative 6x plus 30. One thing I do want to point out is anytime you have a negative number leading, that you are going to want to factor out a negative number, okay? I'll kind of show you why. So between negative 6x and 30, all I can factor out is a 6. Let's say we factored out a 6. Well, negative 6x divided by 6 is negative x. 30 divided by 6 is 5. Look at how these two binomials do not match. That doesn't work. These two need to match in order for this to work. So as you can see, that doesn't work this way. But the only difference is that the signs are the exact opposite. What that means is that we should have factored out a negative, and that's why we always factor out a negative whenever there's a negative leading term, okay? So instead of factoring out a positive 6, I'm going to factor out a negative 6. So when I factor out a negative 6, negative 6x divided by negative 6 is positive 1x, and 30 divided by negative 6 is negative 5, and now we have that common binomial factor, which we can factor out. We can factor out an x minus 5, and our other binomial is made up of the leftovers out in front, which is x minus 6, and this would end up being our final answer. All right, good. So I'm going to go ahead and give you another problem. How about what if we had something like 2x squared minus x minus 6, okay? Go ahead and pause the video and try this one out. I'll go ahead and go through the explanation in just a second. Okay, so hopefully you went ahead and tried this one out. So in this case, we have our trinomial. It's in standard form. it has values of a of 2, b is -1, and c is -6. So we have to find two numbers that multiply. In this case, a -12. 2 times -6 is -12. And add to b, which is -1. And those two numbers are -4 and +3. -4 times 3 gets us -12. -4 plus 3 gets us -1. Okay, so now I can go ahead and I can split the middle. I bring down my first term. Let me go ahead. I bring down my first term. I bring down my last term, and I split the middle. So -4x, +3x, -6. So remember, I'm just splitting the middle. Remember, this isn't changing anything because -4x plus 3x is -1x. Okay, so we're not actually changing anything. And now we go ahead and we factor by grouping. So we group the first two terms, we group the last two terms, and then we take out a greatest common factor of each group. So in this first group, between 2x squared and -4x, I can factor out a 2x. And when I factor out a 2x, that leaves me with x minus 2. And between 3x minus 6, I can factor out a +3, which will leave me with x minus 2. And as you can see, I have that common binomial factor of x minus 2, which means I can factor out and x minus 2. And I'm left with the leftovers as well of 2x plus 3. So this is what you should have gotten as your final answer. Okay, so that's factoring quadratic trinomials. Make sure that you're definitely practicing this. In our next couple of videos, we're going to see how we can use factoring these trinomials to help us solve equations and to also help us solve inequalities, something that you might not have done before, okay? So make sure you stay tuned and check out those videos to see how we can use factoring.